Hi folks. The next topic that we're going to learn about are the gas laws. And I bet that you know a lot of the material that we're going to talk about. I bet you already know it intuitively. We're just going to give some more precise definitions to the behavior of gases. So first of all, the kinetic molecular theory, KMT. We've actually talked about this before when we talked about the differences between solids, liquids, and gases. So we talked about how all matter is made of tiny particles that are in constant motion, whether you have a solid or a liquid or a gas. However, here we're going to go specifically into more detail about what particles are doing in a gas. So the kinetic molecular theory makes three assumptions about gases. Firstly, that the particles are small and spaced far apart. They're spaced far enough apart that we basically ignore the volume, we ignore how much space the particles themselves take up. The next assumptions that we make are that the particles move nonstop, they move quickly, and they move randomly. So there can't be any forces of attraction between the particles because then they wouldn't be moving randomly. They'd be moving towards each other, or if they were there were repulsive forces, they would be moving more likely to move away from each other. And we also assume that particle collisions are perfectly elastic, and that means that no kinetic energy is lost when particles collide with each other or collide with the walls of their container. It's also important for us to know what units we will use when we're talking about gas laws. So first of all, pressure. Pressure is a measure of force per unit area. So if you think about somebody standing on your back, might feel nice if they're wearing sneakers, but if they're wearing high heel shoes, that probably won't feel so good because you've got a lot of force in a very small area. Gas pressure is a measure of the force per unit area of collisions of gas particles. Collisions of gas particles with the walls of their container. The more particles you have, then the more collisions you have, and therefore the higher the pressure. The lower the volume, so if you don't have as much space for the particles to bounce around in, then you have more collisions with the walls of the container and therefore more pressure. And the higher the temperature, remember with higher temperature, then you have the particles moving faster, and that means that you have more collisions in a particular amount of time, and those collisions have more force. And therefore higher temperature also causes a higher pressure. So when we're talking about pressure, pressure is a bit of a mess when it comes to units because we have kind of the standard units, then we have the SI units, and people still use the standard units even though we have the SI units as well. There are three main units used for measuring gas pressure. Atmospheres, ATM, are one common unit used, and 1 atmosphere of pressure is on average what you would experience at sea level in terms of air pressure around you. 760 millimeters of mercury is the same as 1 atmosphere of pressure. Millimeters of mercury are used because barometers, which measure pressure, often have a column of liquid metal mercury inside of them, and so we still use those millimeters of mercury as units to measure pressure. And kilopascals. Kilopascals are the SI unit of pressure and kind of the most scientifically correct, but because we've had these other units for so long, it's hard for people to give them up. One thing to note is that millimeters of mercury, mmHg, can also be called torr, because millimeters of mercury is a bit of a mouthful and torr is shorter to say. You can convert between these units using multiplication, using conversion factors. The conversions that you need to use are right here. So for instance, if you want to know how many kilopascals are in 801 millimeters of mercury, you just start with your 801 millimeters of mercury. You start with your known and you use your conversion factor. We want to get rid of millimeters of mercury and we want to convert to kilopascals. So I use my 760 millimeters of mercury down below, so that my units cancel out. And then I use my 101.3 kilopascals on top and get my answer. You can use 101.325. Usually if you just go 1 sig fig more than your starting value, that's enough, because when you round it off, you have to round your final answer off to 3 sig figs anyway. So that's how you can convert from one unit to another. You'll see later on in this module why it's a bit of a pain to have so many units for pressure, because we're going to learn a gas constant and there's going to be a different gas constant for every unit of pressure. So it's important to be able to convert between these different units. All right. What other units do we have when we're talking about gases? We've talked about pressure, but there are different variables that affect pressure. One of those variables is the number of particles. And this was what we spent so much time talking about last module, measuring how many moles of a substance you have. You can also measure gases in moles. So that's an important unit to know about when we're talking about the gas laws that we're going to be talking about. Volume, how much space something takes up. That quantity is measured in liters. 1 liter is 1 cubic decimeter, which is 10 centimeters by 10 centimeters by 10 centimeters. So that's how we measure volume in the gas laws that we'll be examining. The next unit we're going to be talking about is temperature. And remember that temperature is a measure of the average kinetic energy of the particles in a substance. And the kinetic energy is related to the speed of the particles. Temperature. The units for temperature when you're doing gas laws must be converted to Kelvin. You convert to Kelvin if you have a temperature in degrees Celsius. You convert to Kelvin by adding 273. 0 Kelvin is absolute zero. At absolute zero, particles stop moving, and it's the lowest possible temperature. You cannot get lower than 0 degrees. This is why it's important to use the Kelvin temperature scale, because 0 Kelvin has a meaning in terms of particle movement. Degrees Celsius, 0, we just picked as a handy number because that's the temperature at which water freezes, and that's useful as human beings. But 0 degrees Kelvin actually has a meaning in terms of physics and particle movement. So the standard temperature for measurements in degrees Celsius is 0 degrees Celsius. And if we want to know what that temperature is in Kelvin, then we would take our 0 degrees Celsius and add 273 to it and get 273 Kelvin.